today I'm going to talk about United Technologies a bit, and then some real great examples of what we've done in various buildings around the world, new and landmark facilities, and give the results of that we've achieved. But I'd first like to say, it's a real honor to be here with this distinguished crowd, and I thought that this morning's statistics that 57% of the people at this conference are from outside the U.S., that's pretty cool, pretty exciting, and I think gives us great opportunity to share best practices and learnings and technologies from all over the world. So I think this is a lot of fun here. So a little bit of background on United Technologies. We are a $65 billion corporation. About half of the corporation is the aerospace side of the business. You might know of Pratt & Whitney jet engines, and we have an aerospace electrical, we do electrical systems, brakes, wheels, nacelles on airplanes, everything from nose to tail. We currently have Sikorsky helicopter as part of the portfolio, but we're selling that one, so we're going to miss our Black Hawk helicopters there. On the commercial building side of the business, we are about a $29 billion business. We have 74 factories, 49 R&D centers around the world. We operate out of about 2,500 branches, 120,000 employees, so big business. We do everything from Otis elevators to Care air conditioning, Edwards fire systems, Linnell access security systems, Interlogix security systems. Overseas, you might hear of Chubb Security, where we actually do monitoring of security systems in both residential and commercial buildings. So we have a lot of brands and a lot of technologies in the business. We actually have more systems in a building than any other company in the world. So it gives us a lot to work with. And what we found from our experience with customers from around the world is that by integrating these various systems into intelligent products and systems in a building, and again, if we can integrate Otis elevators with Care chillers to Edwards fire systems, the security system, I'll give examples of that, we can actually create a lot of value, and this value benefits people, the planet, and I would say as we think about, the developers in this room and the engineers that we work with, owners in this room, facility managers, we all win when this happens. We consistently we've implemented integrated intelligent building solutions that have achieved upwards of 30% energy savings. I'm going to give one example on that, and that all translates into millions of dollars in cost savings. So these numbers are big. It has great implications for the building community, particularly tall buildings. And what I'll share with you today, not only will focus on these substantial bottom line results of integrating intelligent systems in a building, but also why the technology and the infrastructure are now ready for these new solutions. So at UTC, we like to say that we make buildings more comfortable, secure, safe, efficient, because it's quite simply a business imperative. That's what we're in the business to do. With buildings consuming more than 40% of our energy and the global population moving to urban areas and creating megacities, it's clear that buildings have a significant impact on people and the planet, and by developing healthier, more sustainable buildings, we can truly make the world a better place. We take that very seriously in our mission and our cause. There are important factors that are driving this shift, finally, toward intelligent buildings, which we presented in our research paper, and of course that's available on the CTBUH website. And these are cost savings, reducing the environmental impact, and increasing occupant health and well-being. Relative to the cost-saving side of the equation, the economic impact of efficient, intelligent buildings is considerable. A recent study showed that in the U.S. alone, building owners spent $432 billion on energy in 2011, which is equivalent to what U.S. businesses spend on health care, and more than what we spend on payroll taxes. So it's a staggering number there. The study further concluded that a 30% reduction in building energy consumption is both technically viable and economically attractive in today's world. This opportunity equates to a 28% rate of return for business owners and a $65 billion per year savings to the overall U.S. economy. Imagine taking that at a global level and the kinds of savings that we could see globally. On the people side of the equation, building performance, indoor air quality, we all know the impact it has on occupant health and productivity. I'll talk about that. You know, certainly research has shown that when indoor carbon dioxide levels rose from 600 parts per million to 1,000 parts per million, occupant performance related to tasks that involve strategic thinking and decision-making, which we all do every day, decreased 11 to 23%. So big impact there. And one of the things I want to mention here, hot off the press, just today at 10 a.m. this morning, the results of a recent study that United Technologies participated in with the Harvard School of Public Health Center for Health and Global Environment, along with SUNY Upstate Medical Center and Syracuse University. We just came out with the results of that study this morning. What's fascinating about it is that the Wall Street Journal has already called and wants to publish an article immediately on this. The new study, called The Impact of Green Buildings on Cognitive Function, found that participants' cognitive performance scores average 101% higher in green building environments with enhanced ventilation compared to a conventional building environment. Crisis response scores were 97% higher for the green building environment and 131% higher for the green environment with enhanced ventilation and lower carbon dioxide levels. So this study, we're pretty excited about it, and we will do a whole series of, events centered around this. In fact, we're going to probably bring it to New York City and do a forum specifically on the study in New York City. But what we're hoping for is that it builds the case for healthier buildings. And at the end of the day, when it impacts the people who work, live, and play in our buildings, it has a significant cost to all of us. So, what are the other compelling statistics driving improvements in intelligent buildings? When we look at the United Nations World Urbanization Prospects, they provide evidence for the rapid growth in cities. Already, 54% of the world's 6.7 billion people and counting are living in urban environments. And by 2025, it's estimated that 2/3 of the world's population will live in cities. As more people move to urban areas, the number of large cities is also growing exponentially. In 1990, there were 10 megacities with 10 million inhabitants or more. In 2014, there were 28 megacities worldwide, and by 2030, the world is projected to have over 40 megacities. Incredible numbers there and grows. So this this has a dramatic impact for buildings, tall buildings in particular. And then adding to the case for change, the Intergovernmental Panel on Climate Change suggests that urban areas are responsible for up to 76% of global energy and generate about 3/4 of our carbon emissions. So, if you're not a believer, I know everyone in this room is, and we all have a job to educate others. But research and statistics certainly make a clear and compelling case for this community, the building community, to accelerate the deployment of intelligent technology and building management to existing and new buildings. But I'm often asked, both internally at UTC as well as externally, people say to me, geez, Kelly, we've been talking about this for, 1 decade, 2 decades, 3 decades. So why do you think that now, intelligent buildings will become mainstream? And I really think it comes down to 2 really important factors. One is environmental awareness. I think people are becoming more aware of the impact of buildings and energy consumption around the world. And then also the second factor here is the ubiquitous, cost-effective technology, including sensors, the cloud data and data analytics that now make it possible. So a decade ago, 2 decades ago, we didn't have the web, the cloud, data analytics, sensors like we do today. Now it's much easier to make all of this happen. More companies are becoming aware of their energy, so again, the awareness is building. Aware of their energy, water, other natural resource consumption. Today we have over 60% of Fortune 100 companies do have a commitment for long-term results, and 30% have identified goals for 2020. As a long-standing Fortune 500 company, United Technologies has set the standard for sustainable leadership, or what UTC calls natural leadership. Since 2006, UTC has reduced greenhouse gas emissions by 30%, water consumption by 33%. Moreover, UTC is a founding member of the Green Building Councils on 5 continents. We were one of the first companies to join and support the U.S. Green Building Council in 1993. So we are a believer in this. We prove it out in our own buildings around the world. And then complementing the increased environmental awareness and the information technology revolution, this now provides easy access to data. You see some of the statistics here. I mentioned sensors. I think sensors are important to what we're all doing here. That business alone will be about $10.5 billion and is said to be the next Industry 4.0 or industrial revolution. That's allowing for this to happen. And it's not just about the devices, it's also about the wireless connectivity. By 2017, 80% of the global adult population will have mobile subscriptions. And then, you know, the whole data population is really, really important about, business data is doubling about 1.2 times every year. And the important part is, what do we do with this data, right? So as we think about it from a United Technologies point of view, it's all about how do we take all the data from all of these different systems. Patrick talked a little bit about that and what they did in that building there. I'm going to talk about it I'm going to give 5 examples here. First one is the Shanghai International Finance Center. Great example here. I was there back in December of last year. This is a building that is, it was completed in 2010. It's a LEED Gold certified site with 2 250-meter tall grade A commercial towers. It has a Ritz-Carlton hotel, shopping mall, residencies. It's about 4.3 million square feet, served by a central chiller plant that provides 20,000 tons of cooling. Carrier was the original provider of all the high efficiency equipment back in 2010. And when it first opened, it was typically consuming about 185,000 kilowatt hours of electricity per day. That was about $20,000 cost per day, or 127,000 renminbi. We went back in with them in 2013, brought some of our brainy PhD engineers and did a little bit about, around what Patrick talked about, and that is we went in and took a look at, we monitored through the building management system, which is a automated logic web control system. We monitored the efficiency of the plant room, chillers, towers, pumps, along with weather data, occupancy data, when the data, what was happening in the data center. And we developed smart algorithms built into the building management system that stages the chillers, the towers, the pumps. And the net result of all of that was that at the end of the day, we took out, in a fairly new building with high efficiency equipment, another 27% energy consumption. We saved them about 1.6 million in operating costs per year. And we did the before and after with them. In fact, they helped sponsor a white paper on this. It's a great story. What we did with the smart algorithms is we've developed that into a standard module, if you will, called Plant System Manager. And we can take that out now on a repetitive basis, proven case, to other buildings around the world. So we took the learnings And then, again, what we try to do at UTC is, okay, let's get that out into the field with all of our people to help pass on to other buildings around the world. Switching now to the Sistine Chapel. Sistine Chapel, we worked with them back in 1990. And back in 1990, they were bringing in something like 2 million people per year, around 700 visitors at a time. And we designed the system, the carrier system at the Sistine Chapel around those numbers. And obviously the whole idea there is to preserve the frescoes from the 1500s. Fast forward to about 4 years ago, they came back to us and said, listen, we have a problem. We're now taking through 5 million people per year. About 2,000 people at any given time can go through that facility, and it's having a tremendous impact on not only temperature, but humidity, CO2 levels, and big concern around what that was going to do to the frescoes. And then also, obviously, the people coming through. It's very uncomfortable in the heat of the summer in that facility. So we put a team of engineers together, and this was no small feat. I will tell you, it took us about 4 years. Part of that was the initial design where we simulated airflow patterns and designed a new supply air system and diffuser, which is what you see here, using these computer simulations of the interior airflow. We can ensure that more than 30,000 cubic feet per minute can be delivered to the space while maintaining both low air velocity around the frescoes and reducing erosion and movement of dust there. Also, noise levels were an issue. They wanted it to be a whisper, quiet library. We integrated a video system with the HVAC system so we can do real-time people counting. We know exactly how many people are in the chapel at any given time. We adjust the HVAC system around that and the velocity around that, and all of it is managed through the automated logic web control system. So, very interesting how we can take these same technologies and put it together in a landmark facility, and we all have opportunities to do that around the world to protect these great pieces of work here. Now, talking about system diagnostics research in India, we went into, this is another building where I'd say fairly new building, but we went back in and monitored the building because, they were experiencing issues with the building in terms of performance and airflow, comfort, that kind of thing. So we went back in 2013. We implemented an advanced building diagnostic system in a 200,000 square foot office building that was LEED certified in India. So again, it was already a very good building. The advanced diagnostics allowed the performance of the HVAC equipment within the building to be monitored remotely with no additional personnel on site. We identified more than 15% of the dampers controlling airflow in the building were non-operational in a LEED Platinum building. Typical faults include everything from non-commutative dampers, stuck dampers, equivalent wire, or equipment wired in reverse. We went in, helped them correct the situation, and obviously improved the performance of the building. We found an additional, something like 45 additional equipment faults in that building. So, I think this is another case where, you can take a fairly high-performing building when it was built. Oftentimes, they're not run in an optimum way. And, at the end of the day, we were able to reduce the CO, implementation resulted in a 20% reduction in airside electrical energy consumption. We obviously delivered superior air ventilation to the building. And then also, we are able to do this all remotely, so it took time out of facility management costs to do all of this. Looking now at vertical transportation, when you talk tall buildings, you have to talk vertical transportation. You know, we have Otis Elevators as part of the company. Otis, actually Elijah Otis, invented the safety elevator over 150 years ago. We're still proud of that. But a lot's changed. Today, Otis is the world's leading manufacturer of elevators, escalators, and moving walkways, moving the equivalent of the world's population every 3 days. That's kind of a fascinating statistic. And then from a sustainability perspective, our elevators can also generate energy, making them 75% more energy efficient than other elevator systems. So basically what we've designed is we take the free energy out of the gravity when an elevator is coming down. We capture that energy now in a regen elevator and then put it back into the energy requirements for taking the elevator back up. And elevators use up to 3 to 8% of the total energy consumption of a building. So by doing this, again, big impact in terms of environmental savings, their energy savings in a building. And you think about, 8.5 million elevators in operation worldwide. That can have a big impact as we do more and more of that. So I want to give an example right here, 7 World Trade Center. I think some people in this room are going to visit 7 World Trade. We went in when that building was being built. We tied the elevator system, the Otis Compass Dispatch, together with the Linnell Access Security. And when you go in there, if you tour that building and you badge in or you have your credentials, through the turnstile, it tells you at the turnstile what elevator bank to go to. Go to elevator bank G. When you get there around the corner, it's waiting for you. And all of this is, one, it's better security because they know where people are in that building. They can tell time of day, when are the heavy flows coming in the building, where are these people going? And then also, it saves on wait time. So, it'll save upwards of, 90 seconds in terms of elevator wait time. I thought about taking 90 seconds and saying, let's just pause for 90 seconds and see, it might sound like a small number, but at the end of the day, we all, get agitated when we have to wait that long. So I won't make you wait 90 seconds, but it is kind of a great story in terms of what can be done when you tie systems together in an integrated way. Another example is in Weston, the Peugeot Weston in Guangzhou. This Weston is attached to the Guangzhou International Convention and Exhibition Center, so there's high volumes there. It hosts the famous Canton Fair, numerous other major international events, and opened in 2011. And the hotel has 325 guest rooms and suites, total floor area of 890,000 square feet. So, large number of people in this facility at all times. So we work with the Weston on strategically integrating technologies. So we integrated the HVAC system with Carrier, the Otis elevators, the interlogic video, Chubb security services, and then tied it together all through the automated logic web control building management system. And this helped to more efficiently and effectively move people throughout the building. It addressed a lot of the concerns that they had in terms of people flow, security, and then also by knowing people count. So, using video cameras to know where people are, when there's a crowd gathering. Instead of, everyone going up, pushing a button, the elevators don't know is it one person or 25 people waiting there. Through the video cameras, we can do the people counting, and we can send down, again, through smart elevator or algorithms, we'll send down a whole bank of elevators to pick people up. And this has reduced elevator maximum waiting time for guests by up to 40% during peak time. So they were pretty happy with us on this one. So just in conclusion here, I had 2 other quick conclusion slides. One is, as we think about retrofit opportunities, and I did talk about, landmarks with Sistine and other buildings that were already in existence, albeit fairly new buildings, and what we did there. 72% of buildings today are 20 years or older, and you heard Larry Silverstein this morning say that the majority of buildings in New York City are over 80 years old. We can integrate systems in existing and new buildings. This isn't just about, putting intelligence in new buildings around the world. This is about, whether you're in a developing country, a developed country, new building, existing building. It's an opportunity in all of those, and I think, would say that, as we demonstrate savings of 27%, 30% in energy, this can be done in every building around the world. It's all about technology advancements. It's all about collaboration between companies like UTC, other companies in the industry, partnering, collaborating with owners, developers, architects, engineers. It's all very possible in our world today. So I sort of say we all in this room have a responsibility to make this happen. The time is right. I think we have to accelerate the advancement here with buildings and become evangelists for this great industry. So thank you very much.